Hello, I am Santhosh and this is my submission of the assignment for the field engineer position. So the problem statement is I was given an IP camera module, I mean the PCB of it, and I have to go through the schematics of it and be able to answer the following 6 questions. And also I wasn't given any additional information such as manufacturing details, data sheets and all. These are the basic assumptions which are being made. So keeping those assumptions in mind, I would also like to make an additional assumption, that is the camera is actually working. I mean the IP camera is actually working. So keeping those assumptions and moving forward, what we would be getting is this. So upon closer inspection of the board, we will be able to see most of the parts aren't labeled. As in, if we see this as an IO port, we will be able to know that this is an IO port because it's labeled, but we don't exactly know what are the pins over here. So that is one of the thing. Not just this, almost all the parts over here, like this is a line port, but we are not sure of what is positive or what is negative. Same applies to almost every port. Even looking at the underside of it, we weren't able to figure out much details, as all this aren't technically useful to us in identifying the positive and negatives of it. So what I would actually do is I would take a multimeter and then try to check the polarity of the connections. So keeping in mind and to answer these questions, what I actually propose is, instead of us first primarily trying to figure out the hardware, what if we go through the software side and then to the hardware. So primarily before doing that, what I would do is I would just use my multimeter to make sure I will be following all these paths, these wire positions, to make sure that none of them are actually damaged. If something is damaged in it, and connecting it to power supply or the port would lead to a disaster situation. So I'll actually make sure that all the connections, these connections, the resistors and all, are actually proper and functioning. So once that is done, what I will do is, almost all the IP cameras, the way they function is they need to be connected to your host computer through this. This is basically to connect our LAN wire, LAN cable or Ethernet port. So further first time setup, every camera has to be connected to a PC which is connected to internet. So I would take an Ethernet cable and connect it to the home network or to the PC, and then because I was told here to use Linux in specific, which I am familiar with, what I would do is I would run ifconfig/all. Once I connected this, then I would be getting all the IP addresses as well as the MAC addresses of everything present in my system, like all the network devices, which includes the Bluetooth devices and all also present in my system. Then through those I'll be able to find out specific IP MAC address of this specific device, this network camera. Once I find the MAC address, what I would do is I would open Wireshark tool, which is a packet sniffing tool. In the Wireshark, I would be trying to find out all the packets or the data being transferred by this IP camera. Once I find out the specific IP addresses and all, in general what these IP cameras do is they have a web server hosted inside them. So this web server tries to connect to the modem or access point present in our home network or the network which it is trying to get connected, and it will stream the data over it. That is what this usually do. So because it is connected to a network, it will try to find its broadcast port and get out of the home network, so that it will be able to broadcast its video to a particular IP address. And also these use something called as RTS, real time streaming protocol. These usually work on port 554. Those are some of the standard values which usually are being followed. So keeping those in mind, what I would do is, because I got the MAC address using Wireshark, I'll use an Nmap. I'll use Nmap. It's a network mapping tool which is used to find open and closed ports in a given network. Through the MAC address what I got in the Wireshark and also the IP address, what I'll be able to find out when the Wireshark captures the packets being sent by the IP camera, to find out what this is doing. Using that data, the specific range of IP addresses what I found, and also the port number 554, I would try to see all the open ports present in the specific IP address. if at all 554 is closed, nmap shows you all the open ports present for the specific device. So once I find the specific port and IP address, for our use case, let us suppose the IP address is 192.168.1.10, because 1.0 and all would be for some other purposes. Let us assume this is ours. So what I would do is, I would open my browser and and type this IP address followed by port number 554. If this is the correct port, then I would be able to get to a login screen where I will try to log in. So this is what I would do if I were able to this is an example over here of what possibly could happen. While most of the cameras, what actually happens is, the starting 192.168.1.x would be the thing. So most of the cases this would be standard, while these numbers would be usually changing, but for most cases even only the last subnet would be changing, not even the last second subnet, this octet. And the default subnet mask would be 225.225.0. That is a pretty standard value in all these IP cameras. So I'll try to connect. If I am unable to find the user ID and password, one thing what I would try is resetting the whole camera to factory default settings. So resetting the camera would change it to user default password and settings, such as admin.admin, which would be the user ID and password, or admin and password. It will be taking me to such kind of combinations. Once I am able to log into the camera from a web browser, then I'll be able to figure out all the additional functionalities. In my belief, that would be way more better than us trying to actually find out what each of the connections does when we don't have more details. Now coming back to the hardware question, so what I would do is, the questions explicitly asked are, how would I identify the pin configuration of relevant connections made, and what steps would I take, and what are the tools I'll be using. So coming to the pin configuration, once I get a multimeter, using multimeter I'll be able to find out what each of the connections takes me to. From the PCB diagram I'll be able to check continuity and make some assumptions of what could each of them be. Also, along with those, what I could actually do is, I would be taking a diode of some kind, probably a Zener diode of some kind, that is primarily being used by me to make sure that the polarity and all are being seen. For suppose if I end up connecting things in the wrong polarity, it might end up breaking the things or burning them. So if I use a diode like Zener diode, they will be helping me in making sure the polarity what I connect is right. Even if I connect the wrong polarity, then the device will not work, then I would be knowing that. And also, if I am not exactly sure of what voltage this device takes, what I could actually do is, I would be taking some resistors of a little large resistance like 1 kilo ohm or 2 kilo ohm, and I would be connecting them in series before I check the conductance of everything and the continuity. So that would help me in making sure that I send lesser voltage. And also I will start with some voltage like 3.3 volts or 5 volts, as most of the devices of this range of this IP camera range are suitable to work around 5 volts and above. So for a safer case, I would be trying to use 3.3 volts. That is what I would be doing. And finally, coming to the point of what all tools I will be using, I would be requiring multimeter, oscilloscope to check if any signal is coming. And coming to the specifically software tools, I would be requiring Wireshark, Nmap. That would be all. And also one more thing what we could actually do is, I believe if we are allowed, we could actually scan the board, and once we scan the board, we will be able to find pretty significant details about it. But I'm not sure if we are allowed to Google for this task, or else if we are actually Googling the thing, we will be able to find almost every detail about it. Though I don't believe we are allowed to Google for this task. So yeah, in this case here I was able to find all these things.